Have you ever wondered how computers across the world communicate with each other? Today we're diving into the fascinating world of wide area networks, or WANs. These are essentially networks of networks, with the internet being the world's largest one. Let's start at the beginning. The first known WAN was created by the US Air Force in the late 1950s to interconnect sites in the semi-automatic ground environment radar defense system. But the foundation of the internet as we know it today started with the Advanced Research Projects Agency Network, or ARPANET. This was the first wide-area packet switching network with distributed control, and it implemented the TCP/IP protocol suite. Initially, ARPANET interconnected universities like UCLA, Stanford Research Institute, UC Santa Barbara, and University of Utah. So, what are the components and technologies that make up a WAN? First, there are WAN routers. These devices route data packets between WAN locations, providing enterprises access to carrier networks. WAN technologies include packet switching, where messages are broken into packets and sent independently over optimal routes. Leased lines, which are dedicated point-to-point connections. Frame relay, a virtual circuit-based technology. DSL, or digital subscriber line, which is high-speed data transmission over telephone lines. Cable, which uses cable TV infrastructure for data transmission. And Ethernet, a common LAN technology extended for WANs. In recent years, we've seen the rise of software-defined WAN, or SD-WAN. This approach is designed to make WAN architectures easier to deploy, operate, and manage. It relies on virtualization, application-level policies, overlay networks, and SD-WAN devices and software platforms. One of the key advantages of SD-WAN is that it increases data transfer efficiencies by utilizing lower-cost network links. But what about the challenges associated with WANs? This is where WAN optimization comes into play. It addresses latency and bandwidth constraints through techniques like deduplication, compression, protocol optimization, traffic shaping, and local caching. This improves packet delivery and traffic control, making for a smoother and more efficient communication process. So there you have it. From the first WAN created by the US Air Force in the 1950s to the rise of SD-WAN, these networks have evolved to connect the world and enable seamless communication across vast distances. And remember, every time you use the internet, you're tapping into the world's largest WAN.